This boulder field allows us to look at the hydrodynamics of what happens when a tsunami comes on shore.
Climate change is going to influence every region on the planet.
It is a very important issue that I think everyone should pay attention to.
I think a lot of young people are trying to be part of the solution.
Developing the technologies that can help us buffer the variances provided through climate change.
On CuriosityStream, channel 422.
Hello and welcome. On behalf of the Earth Observatory of Singapore, I'd like to welcome you to the premiere of the Climate Impact Asia at NTU Singapore. You are in the VIP room. It's a special pre-launch event, and my name is Liz Courtney. I'm the artist in residence at the Earth Observatory of Singapore, and I am very thrilled to be your host today for this event, and also the writer and director of the series. Joining us in the VIP room is Professor Benjamin Horton, the director of the Earth Observatory of Singapore, Dr. Sylvia Earle, legendary oceanographer, National Geographic Society explorer, and first hero for the planet by Time magazine, and Associate Professor Adam Switzer, who heads up the Coastal Hazards team and also features in this series. To get started, I'd just like to ask the VIPs to ensure that you have your microphone set to mute. In the VIP room, you'll see a chat panel. Please send any of your questions for our general chat to that panel, and we'll moderate them in the forthcoming minutes. If we can't get to any of your questions or all of them, we will endeavour to follow up afterwards. And thank you for all your messages from Monaco, New York, Europe. We're really thrilled to have all of you here today. At 12:25, this segment will actually finish, and we will move you all to the general room. Please don't move, we will move you, and we'll look forward to welcoming you then to the main launch event. To get started though, we thought it would be a wonderful time for you to have an opportunity to have a chat with some of our guest speakers here today. And I'd like to hand over to Professor Ben Horton, who is the director of the Earth Observatory, just to give us a bit of insight in conversation with Dr. Sylvia Earle about important headlines that are in the Southeast Asia region, particularly the work they're going to be doing on oceans and climate change. Ben, over to you.
Thank you, Liz. Yes, I'm Ben Horton. I'm the director of the Earth Observatory of Singapore, and I'm also a climate scientist. And over the last few years, I've been increasingly concerned about the climate emergency. Here in Singapore, the Prime Minister mentioned a few weeks ago that we should be prepared when we come out of COVID for virus X. I know what virus X is, and it is the climate emergency. The information that we've uncovered as a scientific community is increasingly worrying. And I'll just give you one example from some science that came out this summer. And that was that the greenhouse gas concentrations in our atmosphere are approaching levels that haven't been seen for over 3 million years. And that was in the Pliocene. So why is that worrying? Well, the concentrations of greenhouse gases in the Pliocene raised global temperatures by 3 to 4 degrees centigrade, exactly the pathway that we're on right now. And the consequences of this in the Pliocene were devastating. It destabilized the Greenland and Antarctic ice sheet and caused sea level rise of some 10 to 20 meters. So there's some of the climate threats that we are examining here at the Earth Observatory of Singapore. So Sylvia, what sort of warning signs are you getting regarding the health of our oceans?
Well, you see it on many fronts, Ben. One of the most obvious, I suppose, is very evident right there in Southeast Asia, and that is the bleaching of corals. Warmer water causes the colorful algae that live in the tissues of coral to disappear. For a while, the corals might survive, but they can't live for long without their associated algae. There are other factors that cause stress for coral reefs, but the warming temperature of the ocean, just as the warming temperature of the land and air, really is changing the nature of the world. We see differences in the areas where organisms can live. There's a shift. And then the warming ocean means that seawater expands as it warms. It's part of what contributes to sea level rise. So, it's a combination of factors. People sometimes ask, what's the effect of climate on the ocean? But really, we should look at the other side. What effect does the ocean have on climate? The ocean absorbs most of the heat that is really coming to Earth. It's stabilized things for as long as it has now, but there's a point beyond which everything changes. And as you point out, we're perilously close to reaching that point of, I don't want to say point of no return, but it's certainly going to get harder and harder to reverse the trend that we are now upon.
And Ben, how thrilled are you to have Sylvia joining the Earth Observatory of Singapore to work with you and the team on oceans as an advisory?
Well, the Earth Observatory of Singapore, it's approximately 12 years old now. It has a mission statement that is as relevant now as it was then, and that's to conduct fundamental research on geohazards and climate change in Southeast Asia for safer and sustainable societies. But we are an evolving institute. We originally concentrated in the aftermath of the Indian Ocean earthquake and tsunami on tectonics, volcanoes, hazard and risk. But we've now evolved as there's been increased interest and intensity on climate research, both from scientists, governments, and the general public. So we've evolved, and we need to move our research into the ocean realm. And this is where we were very, very unbelievably honoured that Sylvia, the premier oceanographer over the last few decades, agreed to join our scientific advisory board to provide that knowledge strategy that we need to keep our oceans healthy.
Thank you. Now, I can see that there are so many questions that are already starting to flow in. I think it would be a good time for us to say, use your chat panel, and please, the questions that you would like to address to Sylvia, to Ben, or to Adam, or to Riddell in this session, please do so. I'm going to actually kick off with one question, and then I'm going to start going through the questions that are coming through on the chat panel, and we'll get through as many of those as we can. My first question is actually to you, Ben. I know that I asked you a question about this, and I was so surprised with the answer. Would you mind just telling me, why is the area of Southeast Asia, and particularly around the equator, so critically sensitive to the melting on the Greenland ice sheet, the Arctic and Antarctica? Why is it this region and possibly not something else down in South America or Alaska?
Well, Liz, that gets to the fundamentals again of the mission statement of the Earth Observatory. We have to do fundamental science on the issues of climate and sea level rise, because sea level rise is a complex process that the magnitude or rates of sea level rise will differ from, let's say, Singapore to Hong Kong, will differ from Southeast Asia to North America. And that's because there are a variety of processes at the local, regional, and global scale that vary in time and in space. So you put an example of one about the threats associated with ice sheets. Well, we have ice sheets in the Arctic and Antarctica. They are colossal. So Antarctica, for example, it's twice the size of Australia. It's up to 4 kilometers thick, and it has enough water within it that if it was to melt, it would raise global sea levels by a colossal 65 meters. But then there are complexities that these ice sheets, because they're such a colossal mass, they attract things to it, such as the ocean waters. So ocean waters are attracted to the ice sheet loses mass, that attraction is weakened, and ocean water flows out to regions distal from the ice sheet, such as the tropics. So if Antarctica contributes 1 meter of global mean sea level rise in the next 100 years, Singapore would receive 1.2 meters, or 20% greater than the global average.
Thank you for that explanation. And I'm going to move to the second question that has come through. This has come through really addressed to you, Dr. Sylvia Earle. The question is from Christine in Sydney, Australia, actually. Sylvia, congratulations on your recent appointment to the Earth Observatory of Singapore. What critical issues do you see are in the oceans in Asia? And what key projects do you hope to get underway in the coming years that might improve ocean health in the region and also around the Great Barrier Reef?
I'm very impressed with the technological capabilities that now exist and that can exist to explore not just what we now know, but to go to places that have been inaccessible until now. We're really hoping to be able to supply for the region little submersibles that can go to 1,000 meters. Now, given the depth of the ocean as a whole, that's still just the upper part of the ocean, but it gets down below where light penetrates, and it gets into much of the area that is of considerable interest, looking at old shorelines, looking at the distribution of life. The twilight zone holds one of the greatest concentrations of life on Earth. And we don't know much about it because we haven't had access until just about this point in time. So, coupled with the skills that are already there, using new technologies to explore, to gather data, to be able to track change over time, I think we can really make an important difference in terms of understanding and solving the problems. You know, you can't solve a problem if you don't know you've got one. You only care about the things you know. Being able to extend our capacity to dive into the ocean, to take people there, scientists, leaders, even kids, have a chance to see what the ocean is about below where divers can go. Divers can readily go to perhaps 30 meters. Beyond that, you know, you really need remotely operated systems, which are great. We need cameras, we need all the tools. We're so lucky to come along at a point in time where these technologies exist. And our goal, I think, now will be to apply them to good advantage.
Thank you so much. We have a question for Professor Switzer, and probably for Riddell could answer this as well. The question comes from Hartigan, and it says, this is very relevant, the conversation, and for the Philippines and around typhoons. How is the changing climate impacting coastal hazards like typhoons that your team is working on? And what are you able to learn from anything in the past that will actually help us better prepare for the future?
Yeah, it's an interesting question, and it's a fundamental question we address in the Climate Impact Asia episode on coastal hazards. Is, you know, to understand the future of what's happening with sea level rise and typhoons, we have to first understand the past. And so, in the Philippines, we had an amazing opportunity where we have a historical record built primarily by the Jesuit priests and others in the early communities that give a wealth of information about typhoons of the past, and cyclones of the past. And then beyond that, you have the geological record. And so if you're looking at things like 1 in 100 or 1 in 200 year storms, you have to integrate those records together. And that's fundamental to what we sort of address in the episode on coastal hazards. And then you can start to think about preparing coastal communities for a future where maybe you're going to have more intense cyclones and the storms are going to get worse and they're occurring on top of a rising background of sea level.
Thank you very much. Riddell, would you like to add to that?
Yes, thanks for the question, Ken. And just to mention that, you know that the Philippines get hit by like 10 or so typhoons every year. And with climate change, the IPCC projects that there will be probably less typhoons, but more intense typhoons, as mentioned by Adam earlier. And so we can expect that our coastal communities, and more than 50% of people in the Philippines live in coastal zones, and they will be at risk, and even more at risk as climate changes. And if you combine all the ecological, environmental problems we have, from the watersheds to the coastal zones to the coral reefs, so you have here like a perfect storm. And that's something that we should be concerned with. Thank you.
Thank you very much. Sylvia, this is one for you and for Ben. From Yvonne Sun. What sort of effects on the global ocean conveyor belt are being observed currently, and what is the projected effect on them in the future?
Go, Ben.
Well, there are many impacts of climate change on what's called the ocean conveyor. So the ocean conveyor takes heat from the tropics to the poles, and it basically equilibrates the climate on our planet. So I'll just give you one example. The starting point of the ocean conveyor is in the Gulf of Mexico, and then the current wraps its way along the US Atlantic coast, becoming saltier and therefore denser when it approaches the North Atlantic around Iceland. At this point, the water sinks and begins the conveyor from Greenland in the Arctic all the way to the Antarctic, and then pops up in and around the Indian and Pacific Ocean to complete the conveyor. Now, I mentioned that this water sinks around Iceland because it's saltier and therefore denser than any other part of the ocean. But we can change it through climate change. The melting Greenland ice sheet produces icebergs. The icebergs go out into this current, changing its salinity, stopping the ocean conveyor. This has happened in the geological past, causing catastrophic changes in climate, where we have in the North Atlantic changes of up to 10 degrees C within 50 years. So catastrophic changes within a human lifetime. So we're playing around with things where there are tipping points, where there are thresholds. We know the science, we need to act.
I will applaud that and underscore it. The problem is not knowing, the problem is the will. Taking the knowledge that we have, taking it seriously, and turning that into action. To be aware that this is real, this is not just theoretical. We now know what to do. It's a problem of actually doing what it takes to get from where we are to a more secure place.
Thank you, Sylvia. We have a question that has come in from Natalie. Why did the concentration of greenhouse gases increase when currently COVID-19 has been causing human activity to decrease drastically? I'd like to throw that to the panel and see who would like to answer it first.
I can start. The aspect about the greenhouse gases is it's a cumulative process. Carbon dioxide stays in the atmosphere for several hundreds of years. So the greenhouse gases that we started to produce at the beginning of the Industrial Revolution still exist in our atmosphere. So we are correct that the COVID pandemic, when we shut down our economies, decreased greenhouse gas emissions. Some of the data shows that in April 2020, greenhouse gas production was 40% of the values in 2019. But the actual impact on our climate is minuscule, less than 0.1 of a degree centigrade. It is the cumulative increase. That's why it is important to meet the Paris Agreement, which caps emissions by 2030 and then gets to a zero carbon economy by 2050, because then that gives us the long-term decrease in the amount of carbon dioxide in the atmosphere. That's so important to stop the devastation of our oceans, catastrophic sea level rise, and a host of other problems associated with the climate emergency.
Would anybody else like to add into that?
If I could, just a recognition that what has made it possible for us to have the atmosphere that we enjoy. It has taken a very long time. I mean, we're talking hundreds of millions of years for the atmosphere generated by photosynthesis, carbon capture, oxygen production, just the whole cycle. It's a biogeochemical process that has shaped the Earth. Not just rocks and water, not just a physical process, not just a chemical process, but a biogeochemical process. Now, we have seen in recent times a destruction of the natural carbon capturing mechanisms called forests on the land. And in the ocean, we're seeing a decline of the phytoplankton, the forests of the sea, if you will, the places where photosynthesis acts on a much larger and older scale than what has happened on the land. But for the ocean, I mean, before there were green plants on the land, the ocean was already capturing carbon, generating oxygen, and starting the process that we now take for granted. We do. We sort of believe that the atmosphere has always been here. No, it's taken a long time to get here. It's taking us a short time, relatively speaking, to compromise the sources and to add to the atmosphere more carbon dioxide, more methane, more nitrous oxide than is suitable for our existence. But I think the great good news is knowing what we know. Imagine if we did not have the science to understand, if we were oblivious to the processes, that would be a real problem. But we know, we can see it, we can measure it, and we can do something about it.
Thank you, Sylvia. We have time for 2 more questions. One question has come in from Jamin, and it says, science has been prompted to respond to the pandemic, but governments have been slow in implementing policies. Does this give you much confidence in dealing with climate change, given the gap that has occurred already? Riddell, would you like to take a lead on that one?
Yeah, Liz. Well, on the question of the pandemic, 2 things. First, in some ways, it gives us hope that given the right motivation, governments can act. And the pandemic was that motivation. And we see people changing their lifestyle and really changing the way they live. So that gives me hope. But on the other hand, the risk is once the pandemic is over, we go back to business as usual and we don't learn from the pandemic. So I guess the pandemic is a perfect opportunity to learn and see how we can change things in a paradigmatic way. And I think that's a challenge for our governments, Liz. Thank you.
Thank you. We have time for one last question, which is coming from someone who's up very late at night in New York. And it's to you, Sylvia, but to the panel, from Moira Curtin at Columbia University. How do we, and do you still stay positive after seeing all the changes in the oceans over the last 50 years? And are you still hopeful that we can stand together to be able to bring about the change we need, not just for us, but for future generations?
Short answer, yes. You know, if you don't try, if you just give up, it will be a self-fulfilling prophecy. We cannot go back to the way things were even 1 year ago, but we can make things better than they otherwise would be if we just learn from what is happening right now, plus all previous history. We are armed as no generation has ever before, armed with knowledge. That's what gives me hope. We know that when we do change our behavior, armed with knowledge, we can make a difference. It works. And that's what gives me cause for optimism.
And what a wonderful way to finish this first session, the VIP session, with hope and optimism. So please stay with us as we transfer now to the main session, and we will be with you in about 3 or 4 minutes to kick that off. Stay where you are and we'll be transferring you now. Just make sure everybody's on mute. Thank you very much for joining us on the VIP, and we're now moving to the main launch.
Thank you, Liz. That went very well.
And questions from all over the world. Like, it's incredible how many people are here from all over the world, and it's so wonderful to have everybody here, and I'm really looking forward to the next part of the event, which will start in about a minute and a half. So Leonard, we'll be good to go at 12:30. Thank you.
This boulder field allows us to look at the hydrodynamics of what happens when a tsunami comes on shore.
Climate change is going to influence every region on the planet.
It is a very important issue that I think everyone should pay attention to.
I think a lot of young people are trying to be part of the solution.
Developing the technologies that can help us buffer the variances provided through climate change.
On CuriosityStream, channel 422.
Well, welcome everybody to the premiere launch of Climate Impact Asia. We're so thrilled to have so many of you attending from all over the world. And this is a virtual launch, something we are all getting used to. I'm Liz Courtney, and I will be your host for this event. I'm also the artist in residence at the Earth Observatory at NTU, and I'm the writer and director of the series. We have a very special hour of discovery, exploration, and engagement planned for you today, as we celebrate the premiere launch of this documentary series, initiated by the Earth Observatory of Singapore at NTU and our broadcast partner, CuriosityStream. I'd like to extend a very warm welcome to our keynote speaker, Dr. Sylvia Earle, who's joining us from the US today. Good evening, Dr. Earle. Lovely to have you with us. Dr. Earle is our legendary oceanographer, National Geographic Society's explorer, first hero nominated by The Planet by Time magazine, and we so look forward to your keynote address. Can I ask anybody, if you'd like to send an emoji, please do, or clap a hand, and we welcome you, Dr. Sylvia Earle. Just before we get started, a few quick housekeeping notes to make sure everybody has their mic turned off. We will have a Q&A session at the end of this, and it will be a hand-up session, and I will moderate those. Now, to get started, I would like to give a warm welcome to Professor Benjamin Horton, who is the director of the Earth Observatory of Singapore at NTU. Professor Horton's research concerns sea level rise with the aim of understanding and integrating the external and the internal mechanisms that have determined sea level changes in the past and which will shape such changes in the future. The research impacts upon important ecological, ethical, social, economic and political problems facing coastal regions in Southeast Asia. So please give Professor Benjamin Horton a big round of applause with a hand clap or an emoji, and we welcome you as our first speaker. Thank you so much.
Well, good morning, good afternoon, good evening, everyone. I'd like to thank you for attending this virtual premiere of the Climate Impact Asia series. I'm going to take the next 5 minutes or so to share with you some of the most important ideas of the Earth Observatory of Singapore, for which I have the great honour of being director. So the story of the Earth Observatory of Singapore began in the aftermath of the Indian Ocean tsunami on December the 26th, 2004. The Sunda megathrust ruptured with a magnitude 9.2 earthquake, the third largest on record. This produced a devastating tsunami that impacted the communities of Southeast Asia and beyond. In 2008, the Earth Observatory of Singapore was founded as a research centre of excellence at Nanyang Technological University. On your slide in front of you has the mission statement. The mission statement is as relevant now as it was then, and that is to conduct fundamental research on earthquakes, volcanic eruptions, tsunamis, and climate change. in and around Southeast Asia, and importantly, towards a safer and more sustainable society. We have an EOS logo, which you can see on the slides. You can see when you come into the Earth Observatory at NTU. What does it represent? Well, the 4 colours are the 4 research themes of EOS. They are interconnected and they are continually evolving. We have 4 research themes: volcanoes, tectonics, hazard, risk, and society. But over our evolution, scientific interest, the general public and the governments has changed, and EOS has responded as well. We now have a greater emphasis on climate change research. The Earth Observatory of Singapore has over 130 researchers, staff, and students. We have a diverse international community from all over the world. We share cultures, we share knowledge, and this has enabled us to have global research within the Earth Observatory. So why is there an observatory at NTU in Singapore? Well, that's because Singapore is in the centre of the Southeast Asian Ring of Fire, the greatest concentration of geohazards and climate hazards on our planet. Coupled with this, we have some of the highest population densities. This means that hazards can quite quickly become disasters. Regarding tectonics, we have hazards in the Himalayas, through Sumatra, Java, Papua New Guinea, the Philippines, and elsewhere in the South China Sea. These tectonic hazards commonly produce tsunamis, so virtually every kilometre coastline in Southeast Asia has an impending hazard from tsunami attack. We also have the threat from tropical cyclones. In Southeast Asia, we have some of the most devastating landfalling tropical cyclones. And with climate change, we are concerned about changes in intensity, tracks, and frequencies. Surrounding Singapore, there are a colossal 750 active volcanoes. And for sea level rise, it is anticipated by the end of this century, 600 million people will have a risk from sea level rise. But the centre of the Earth Observatory, our heartbeat, is the Centre for Geohazard Observations. Here, we collect data from around Southeast Asia. In 8 countries, we have 175 stations that collect data on how the land moves, how volcanoes breathe, and how the oceans are rising. We are able to handle large volumes of data in real time. That enables our scientific knowledge to be transferred to the communities at need to make them more resilient and safer. The Earth Observatory of Singapore has an advancement office where we take our scientific information out to the public. We have produced award-winning documentaries and game applications, and we hope the Climate Impact Asia has a similar influence. We have a variety of exhibits. We have a new one at the Science Centre being developed, hopefully to be displayed at the end of this year. We work with the Ministry of Education. We work with school teachers to take understanding of the Earth to our younger audience. And finally, we provide our information on scientific expertise to the media, TV, radio, and print. And in 2020 alone, we had some 600 and counting editions in TV, radio, and print. So now we move to the Climate Impact Asia series, and I'd like to hand back to Liz Courtney. As she mentioned, she is the artist in residence at the Earth Observatory of Singapore, and she is the writer and director of this series. Liz?
Thank you very much for that introduction. I'd like to say a few words about the work. For me, science in action, exploration and discovery, it's never been such an important time to be able to tell the stories and translate the work that scientists are doing in the field to television, to digital programs, and tell you real science and real stories. I think as a filmmaker, I seek to tell these stories and to take the viewer out of the lab and to see science and discovery really in action to enable knowledge and education around climate change, impacts and solutions. My climate journey didn't really start purposely. It sort of started by default when I was asked to direct a series in Antarctica, and I initially said no, but then with the influence of my children, I decided that I would go. I might have been afraid of the rough seas, but I actually did go. And it really changed my view on the world, and it really gave me the passion and the purpose to step forward and do more work in this sector as a writer and a director. I'm very proud to have been given the award of 100 Women of Influence in Australia for my work in climate education, and it's been such a privilege to be able to step up and work with the Earth Observatory of Singapore at NTU on translational science. In this series, we travel to Nepal, we travel to Thailand, we travel through Singapore, Philippines, to have a look at key areas of impact: sea level rise, coastal hazards, food security, and volcanoes and tectonics. Each of these stories follows principal scientists in the field, and we look at how they gather samples, data, set up recording devices, march me through very swampy mangoes to drill core samples, monitor sea level change in areas, and then we transition back to the lab to understand how that work gets translated back, how the data gets analyzed, and what and how those pictures are formed based on very strong scientific evidence to tell us about the now and the future. So as a director, I really seek to find what it is in the passion of the people and the motivation behind the people I'm filming. And I have to say that I have never found a more passionate and purpose-driven team than those scientists that are here at the Earth Observatory of Singapore at NTU. And I hope you'll find the stories in this series help you understand more about the changing climate system that's impacting the planet, but also how faraway places like Antarctica, Alaska are having a profound impact on the systems here in Southeast Asia. And to identify the role that you can all play in being part of a change for a positive future in the region, not just for now, but for future generations. This is a short trailer that I'd like to play you. I'd like to thank our broadcast partners at CuriosityStream, who really believed in the importance of telling the climate change story from a local perspective, the Southeast Asia story perspective, and StarHub for being the local carrier who will be bringing this story to people in the region starting this Sunday. I'd like you to enjoy the trailer. Thank you.
Climate change is going to influence every region on the planet. What's needed now is a sense of urgency. We have, within the next decade, exceedingly important decisions to make.
Climate change is a very real threat to agriculture. It's also a very real threat to the way of life that we have right now. It is a very important issue that I think everyone should pay attention to.
Going into the future, I think there is certainly scope to be optimistic. Many experts feel that going forward, as weather becomes more variable due to the macro climatic factors, disease control environment farming may become more important. And a small country like Singapore is hoping to play a major role in this, developing the technologies that can help us buffer the variances provided through climate change.
I think a lot of young people are trying to be part of the solution, and I'm really glad that I'm also playing my part.
Studying past events is important to prepare for the future. We have to prepare our coastal developments better, and to do that, we need to understand how often we get storms and tsunamis on any given coast. This boulder field allows us to look at the hydrodynamics of what happens when a tsunami comes on shore.
Here at the Earth Observatory of Singapore, we are creating the largest database of volcanic phenomena.
It's really important that we understand where fault lines are and how big the earthquakes are likely to be when they happen. And this is because if we know exactly where the faults are, we can be very strategic about building infrastructure and protecting human lives.
Right now, there's never a more important time to be an Earth scientist. We need to make sure that policies are made that are based around science. Many people now know that climate change is real, that they see the data or they see the observations for themselves. So here we're going to record mangroves. Mangroves are intrinsically related to sea level. Because we have plant macrofossils here, made out of carbon that you can radiocarbon date, can give you a timing. And then we can correlate those with known climate changes during the period from approximately 500 to 1,000 years ago.
I hope you all enjoyed a little sneak peek of the series coming this Sunday. Now, I'd like to introduce, I know it's very late at night over there for you, Jorge, in Washington, DC, but I would like to introduce Jorge Francini, who's the Director of Content and Developer at CuriosityStream in the US. And he's joining us to share his insights on the important role broadcasters play in the 21st century. So please give him a hand clap and a welcome.
Well, thank you so much for having me and for the introduction, Liz. I also want to thank all of you out there for joining us here today, and to the Earth Observatory of Singapore and NTU for hosting us. For those of you who aren't as familiar with CuriosityStream, we are a global video streaming and a television company focused on premium factual content. The brainchild of legendary media visionary John Hendricks, who also founded Discovery Communications, our goal is to bring the best stories in science, technology, and natural history to over 13 million viewers throughout the world, including right here in Singapore, exclusively on StarHub on channel 422. We like to say that our mission is to entertain, enlighten, and inspire our audience, and that's obviously something that we take very seriously. From day one, the vision for CuriosityStream was for it to be a global service, so our library is comprised of stories from filmmakers from all over the world. Because we want audiences to really identify with the content, but more importantly, to be moved by it. We absolutely love to be able to shine a spotlight on the stories and voices that matter most to our viewers. And to that end, we really couldn't be any prouder to have Climate Impact Asia on our service. I think this series is tackling some of the most critical challenges that we are facing today. But through the hard work of all of those involved, it's an accessible and entertaining journey, exploring regional and strong climate narratives in an engaging and active way. To me, the best films in conservation, they don't preach at us, but instead they leave us with a lasting impression. They inform us on how we can make a change. By connecting fieldwork to the lab, this series provides an insight into the technology that is driving scientific research and the evidence-based results that are providing important data to drive impact planning and change. So half of our audience here at CuriosityStream is age 35 and under, which really lifts us because it means that, for one, there's a huge appetite for factual-based content, but for me, what it means is that we are enlightening and entertaining tomorrow's voices. The climate situation isn't just an Asia problem, it's a global one, and it really couldn't be any more dire. But by inspiring viewers through the hard work, dedication, and most importantly, the impact of the scientists and researchers involved, like Professors Horton and Switzer, we're helping to build a foundation for a better future. It's for that reason that we're hopeful that we'll be able to bring forward more stories from the region with both EOS and StarHub in 2021 across oceans. Thank you very much for all of your time. I want to leave you with a little sample of what CuriosityStream is all about, and I truly hope that you enjoy the series.
thank you so much, Jorge, for being up so late and for joining us tonight and today. I'd like to move on to introduce our next speaker from the Philippines, Dr. Rodel Lasco. Dr. Rodel Lasco is the Executive Director of the Oscar M. Lopez Center in the Philippines. He's a pioneering and multi-award-winning scientist with more than 35 years of experience at the national and the international level. He's the author of over 80 technical publications. His work focuses primarily on natural resource conservation, climate change, and land degradation. He is an author of several reports for the Intergovernmental Panel of Climate Change and the 2007 co-winner of the Nobel Peace Prize, as well as a member of the National Academy of Science and Technology in the Philippines. Please welcome Dr. Rodel Lasco from Manila and show him a hand clap or an emoji. Thank you.
Thanks, Liz, and greetings to all of you from the Philippines. Just like you, I'm quite excited to be part of this event and to be a partner of the Earth Observatory of Singapore. First, let me tell you a bit about our center. The Oscar M. Lopez Center is the brainchild of our chair emeritus and one of the business titans of the country, Oscar M. Lopez. About 10 years ago, and much ahead of his fellow business captains, he realized the threat posed by climate change, not only to his conglomerate, but to the whole Philippine society. He saw the need for an organization that will focus on enhancing the resilience of his fellow Filipinos through sound science. And as you can see from the quotation in this slide, he was fairly optimistic about the innate ability of the people to cope with climate risks. Many of you are aware as well that the Philippines is one of the most typhoon-prone countries of the world. But the real wake-up call happened during Super Typhoon Haiyan in 2013. In one single day, about 10,000 people died, more than $2 billion of damages, and finally it hit people from all walks of life that climate is indeed changing, that we are in a new normal. The OML Center is unique in that it is a privately supported foundation anchored on science. We recognize that the way to build the country's resilience is through policies and practice that has undergone scientific rigor. We partner with the country's leading academic and research organizations to generate solutions for our people. As an archipelagic country with about 7,000 islands, the Philippines is highly vulnerable to rising sea levels. The observed and projected rise is slightly higher than the global average. With global warming, the sea level could rise up to 100 centimeters by the end of this century. This will put as much as 17% of the current population at risk to future sea level rise by 2100. More than 50% of Filipinos live in coastal zones, and they will be exposed to more severe flooding and storm surges, among others. Another important impact of climate change will be on food security. For example, one study has shown that there will be about 14% yield reduction for every 1 degree of warming in a province in the Philippines during the dry season. And as many of you are aware, rice is the most important staple in the Philippines, as well as much of Asia. The private sector could play an important role in developing solutions for climate resilience. For example, in the rice sector, our research shows that most farmers are poor, old, and with small farm holdings. There are opportunities for the private sector to assist them in water supply development, seed varieties development, and in financing and risk management as well. The OML Center believes that good communication is essential to disseminating the right information that leads to action. As an example of our work, we have collaborated with the leading media company in the country to produce a documentary where scientists and ordinary people share their knowledge and experience of climate. The film is unique in that it brought experts and non-experts together to present the dangers posed by a warming planet. Finally, ASEAN countries are highly vulnerable to the impacts of climate change. We believe that a region-wide partnership is essential to confronting the challenge posed by climate change. I'm happy to tell you that over the past year, we have been deepening our collaboration with the Earth Observatory. We plan to develop a coastal risk index and assess the potential impacts of different scenarios of sea level rise and associated hazards in the Philippines. The study will equip decision makers in select coastal cities in the country with scientifically based SLR data that they need to help communities effectively adapt to climate change. And so with this, let me thank you for listening, and I'm looking forward to watching the film with all of you. Thank you.
Thank you very much, Dr. Riddell, for your comments. And we look forward to welcoming you back in the panel conversation coming up soon. But now it is my greatest pleasure to introduce our keynote speaker tonight, or today, to all of you. It's Dr. Sylvia Earle. Let me just tell you and reflect a little bit on Dr. Earle is the president and chairman of Mission Blue, the Sylvia Earle Alliance. She is a National Geographic Society Explorer in Residence and is called Her Deepness by New Yorker and the New York Times, and a living legend by the Library of Congress, and the first hero for the planet by Time magazine. Wow, that's amazing. She's an oceanographer, explorer, author, and a lecturer with experience as a field research scientist, government official, and a director for several corporate and non-profit organizations. Dr. Earle recently joined the advisory board of the Earth Observatory of Singapore, and we couldn't be more proud or happier to have you today to give our keynote address. So we'd like a warm welcome, chat, clap hands, emojis, and we'll hand over to Dr. Sylvia Earle to take us through the keynote address. Thank you so much.
Thank you, Liz, for that generous introduction. I'm truly honored to be here and to be asked to speak at this important and timely conference at the Earth Observatory of Singapore at NTU on Climate Impact Asia. It would be great to be with you personally, but like many others, I'm enjoying virtual travel with a light carbon footprint compared to last year when I channeled Marco Polo. I logged more than 300,000 air miles and spent time in more than 20 countries. This year, I've traveled virtually to more than twice as many countries than I did last year. And since March, I have logged 0 air miles. My body and the planet are really grateful. Virtual meetings are a small bit of good news brought about by the terrible pandemic that has wrought indiscriminate havoc across the world. But another welcome outcome is the realization that we're all in this together. And we not only have been caused to change our behaviors in ways unthinkable just a year ago, but also, if concerns about our health can cause us to shift behavior, there's hope that concerns about planetary health can mobilize action in time to do what it takes to stabilize the planetary processes that we have disrupted. Some say it will be impossible to change our ways to combat climate change. But when people take to heart that their lives depend on it, change is possible. We have evidence of that in 2020. We cannot control the tilt of the Earth, sunspots, or Earth's magnetic field, but armed with knowledge that did not and could not exist half a century ago, we can manage ourselves, recognizing that we are a part of nature and that nature makes the rules. Throughout human history, people have been able to see the moon from Earth, but only in my lifetime, in your lifetime, have people been able to see the Earth from the moon. And vicariously, they have shared the view. That view of the biogeochemical miracle that we call the Earth in a universe of unfriendly places. Now from space, global events are visible in real time to viewers across the globe. Where I am now in California, fires are raging more frequently and more devastatingly, more intensely than at any time in human history, owing largely to the topic we're addressing here, climate change. It's a biogeochemical process. In a way, the whole world is on fire, or so it appears from space. Next, owing to our appetite for burning fossil fuels that underpin our unprecedented prosperity. Fossil fuels have served us well, but now we know the downside. Next, please. Concerns about warming and climate disruption have been growing in recent decades, with a focus largely on notable changes, next, measured in the atmosphere. There's evidence that global warming is leading to more frequent, next, and more intense storms. Whatever you call them, cyclones, typhoons, hurricanes, we're feeling their power. Warmer seawater expands. Ice melts. Next, please. Sea level rises with consequences to coastal cities and low-lying land everywhere. This is just an artist's impression of New York City in the not-too-distant future. But it is true everywhere in the world. It's certainly true here in Southeast Asia. Next, polar ice is melting. Bad news next for polar bears. Bad news, not just for polar bears. Next, please. Bad news for us. Bad news for people. Rapid change of temperature, such as we are now experiencing, is impacting life generally. Change the temperature, change the chemistry, and everything changes, from the abundance and diversity of microbes to the migratory habits of birds, of fish, of insects, and certainly it's affecting coral reefs. A warmer ocean is altering the nature of coral reefs, causing the loss of algae in the tissues of coral, leaving them with a ghostly white appearance, coral bleaching. Excess carbon dioxide in the atmosphere means increased carbon dioxide in the ocean that in turn becomes carbonic acid, acidification of the ocean. It's a terrible twin of warming the ocean. Next, please. Forests on the land and coastal mangrove forests, marshes, seagrass meadows are critically important. They're natural means of capturing carbon and storing carbon from the atmosphere. If protected and restored where they've been lost, they will help combat the effects of burning fossil fuels, truly important to coastal areas throughout Southeast Asia. Next. But the microscopic forests of plankton in the sea do even more to draw down carbon dioxide than coastal and even land-based forests. They sequester the carbon in the living animals that hold carbon in their tissues. But they also provide fertilizer that drives the phytoplankton that in turn yields food for much of the rest of life in the sea. It was exciting to hear blue carbon, whale, fish, and squid, shark carbon discussed by the brainy economists at the World Economic Forum in Davos earlier this year. If whales get a thumbs up from economists for their carbon and climate value, why not sharks? But dead sharks mean, just as with clear-cut forests, that the carbon dioxide that they hold, the carbon they hold, goes back into the atmosphere. It becomes a climate issue when we clear-cut life in the ocean, just as when we clear-cut life from the land. It's only recently that we have really begun to take seriously life in the ocean and the connection of the living ocean to climate change. Next, please. In the deep sea, as well as in the sunlit areas that we're more familiar with, where the whales exist and where many of the fish exist that we know about, the deep sea now is beginning to be exploited, taking creatures that we're just beginning to understand that they're there, to give them names. but to just treat them as ground up food for livestock, to just treat them as pounds of meat and barrels of oil the way we used to treat whales, means that we don't really get the picture, the understanding that the living carbon in whales, in squid, in sharks, in all of these creatures in the sea, of course we will take them for food, but we've taken too much too fast. We need to understand the balance, and right now it's way out of balance, especially in the places that heretofore have been unexploited. They need to be kept intact. We're just beginning to appreciate the immense importance of blue carbon, more than matching the relevance of the so-called green carbon of the land. Knowledge is the key to understanding. Next, please. Understanding the nature of the current climate issues, but also knowing what to do to safeguard the natural systems that have made Earth hospitable, habitable for us. There are systems such as what you see here, the Aquarius Underwater Laboratory, and systems that have been developed and used for science and industry in Japan, in China, and elsewhere in Southeast Asia that extend the time people can spend underwater. Just as people need time to observe and conduct research on the land, in forests, in deserts, mountains, we need the gift of time underwater. Technologies do exist and are getting better, but what is needed is the will to invest in them and use them. Next, please. Along with the systems that can descend to and explore the undersea mountains and volcanoes below where divers can typically go. New camera systems, next. They can operate even in the deepest seas. And next, please. Much as I enjoy traveling virtually and taking cameras into the deep sea, next, please. There is really no substitute for taking ourselves, to taking our presence, our what we carry on our shoulders, our minds, our experience, to go to wherever we want to go, whether it's to the moon, on a beach, or under the sea. In the 21st century, there are systems that are able to take you or me or anyone thousands of meters deep, and return, of course. We must explore the ocean next and understand the blue carbon connections to the land, to the skies above, and of course, to people everywhere. By the time we gather again, face to face, perhaps in a year or so, there might be available at the Earth Observatory at Singapore, at NTU, a pair of 3-person submersibles able to explore the waters of Southeast Asia in depths to 1,000 meters, to witness ancient shorelines, to calculate more effectively the nature of the ocean as it relates to the topic that we're here now to discuss, to visit undersea volcanoes, to look at areas that are inaccessible presently, but we have the technology to get there and to personally explore and to think about what we must do to secure a future that is safe for us. Next, please. So, I look forward now to hearing not only about the problems we face, but to hearing ideas about how we move to where we are in 2020, to a safe future for today's children and for tomorrow's child. Now, on our watch as never before, and maybe as never again, we have a chance to secure an enduring future within the natural, mostly blue systems that make our existence possible. The people of Southeast Asia are at the front line of feeling the impact of rising seas, warming seas, powerful storms, food security, health security. People of Southeast Asia are also at the front line of solutions with technological strength, with knowledge, and with a will to work with nature, land and sea, to secure a prosperous future for generations to come. Next, please. Truly, moving to Mars is not an option. No ocean, no life, no us. Thank you.
Thank you very, very much, Dr. Sylvia Earle, for your amazing presentation. I know everybody will join me in sending you an emoji and a hand clap. That was truly amazing. And thank you so much for sharing with us all of your knowledge that you have gained over so many years working tirelessly to protect the ocean. We are going to call our panelists to probably answer 2 or 3 key questions. We have had a number of questions coming in over this period of time, and I think we'll only get to 2 or 3 of them. My apologies. But again, introducing Professor Ben Horton, Dr. Sylvia Earle, Associate Professor Adam Switzer, who was with me filming and one of the first scientific groups to be on the ground after Typhoon Haiyan hit in 2013 in the Philippines, and Dr. Adele Lasco joining us from the Philippines. The first question I actually have is for you, Adam, and I have to say I was very privileged to be with you in Thailand and see firsthand the debris from the 2004 tsunami. I was very interested to understand the importance of having these field labs and what sort of information hazardous rocks that have been distributed from tsunamis can give us, and how you turn that information into solutions and adaptations for the future. Over to you, Adam.
Thank you, Liz. It's a pleasure to be here. It's interesting, when we thought about the coastal hazards episode of this series, we wanted to get across the importance of understanding both past events and the historical record and even the geological record for projecting the future of things like tsunamis or storm surges associated with tropical cyclones. And then to get across the message that after an event happens, we need to use each of these events as a learning experience so that we can go and work out, what do the boulders that were moved by a tsunami or storm actually tell us about what happens when a cyclone or a tsunami hits a coastline? And how can we then translate that into velocities that we can use to build better engineering? And so the whole message of this series is about climate impacts, but it's about integrating different approaches to make sure that coastal communities in the session that I was involved in primarily are better prepared. And it goes to the mission of EOS of safer and more sustainable communities, learning from every single event so that we're better prepared. Whether it's sea level rise, whether it's storms, whether it's tsunamis, it all impacts food security and sustainability.
Thank you very much. This one comes from Wendy Lim for the Ministry of Education in Singapore. Sylvia, for you, the question is, what factor do you think is contributing most to climate change? Is there one single factor, or are there some key headlines?
I think the arrows point very strongly to carbon dioxide emissions from us, from our burning of fossil fuels. There are a number of different factors, of course, and we talked about them. There are natural means of putting greenhouse gases into the atmosphere. It is vital that we have a means of holding the heat within our atmosphere. If we didn't have that blanket of atmosphere with the greenhouse gases, our world would be very different and would be basically uninhabitable for the likes of us. But too much of a good thing can be a bad thing, and too much warmth is not in our favor, and that's what we were experiencing. If we did not understand the cause and effect, that would be a problem. But we have the evidence. It's exciting to be along at a point in time when we, as never before in history, have the capacity to assess what the problems are. Why is the planet warming more quickly than has happened in geological past? I mean, ice ages have come and gone, but not at the rate, not with the speed that is happening now, and without knowing very specifically, being able to look at the cause, look in the mirror. We are the cause, and therefore we are the solution.
Thank you very much, Sylvia. We have another one that maybe we can address to you and to Ben, and thank you for the questions that are coming through. What are the most powerful and practical nature-based solutions you see we could pursue to save our oceans? And thank you to Christopher Frank for that question.
I can start. Go ahead, Ben.
Well, I think when we look at solutions to climate change, there is obviously the reduction in the production of carbon dioxide and other greenhouse gases. We have to maintain the agreements that were laid down in Paris in 2015, because if we don't maintain those agreements, we pass a series of tipping points because our global mean temperature becomes 2 degrees C warmer than the pre-industrial. We're already at that 1 degree C level. But to return to the question, one of the other aspects, apart from reducing the production, is can we use nature-based solutions to remove carbon dioxide from the atmosphere? This is what the Earth has been doing for millions of years. Our forests, our mangroves, our wetlands, the biosphere in our oceans, they remove carbon from our atmosphere and they bury them. So just one example is that we are thinking about how should we protect our coastlines from sea level rise, and we could replenish, regenerate mangroves. And mangroves have a variety of positive benefits. Yes, they protect the coastlines, they act as fisheries, they filter our drinking water. However, they also absorb carbon through the photosynthetic equation, burying it in the land. So there are a variety of solutions that nature have provided us. But we need to, and I always say this, we always need to understand the science before we start wasting taxpayers' dollars on adaptations. We need to know where it's critical and where we can apply it. Sylvia?
So, one thing that we know works is to actually find those places that are still in pretty good shape and keep them that way, and look at places that have degraded in the ocean and do our best through protection to restore them. It works. In places where we embrace the ocean with care, recovery is possible. We can never go back to exactly to what was, but we can make things better than they otherwise would be if we just allow current trends to continue. So there's a goal for 2020 to have 10% of the ocean under some pretty strict form of protection, which means you just leave it alone. It doesn't mean you don't use it. We use it with every breath we take, with every drop of water we drink. Nature gives us life. The most important thing that we extract from the ocean is our existence. We can get away with extracting some wildlife out of the ocean, but we have to look seriously at the consequences now with an increasing extraction, increasing pressure, coupled with pollution. I mean, the plastics that now are flowing into the sea and the acidification of the ocean. We're changing the nature of the ocean, and we are at risk as a consequence. So the more we can do to identify healthy coral reefs and do everything we can to keep them in good health. The next goal, and it is ambitious but it's possible, is by 2030 to embrace 30% of the coastal areas within national jurisdiction, the exclusive economic zones of countries around the world, and extend it into the high seas beyond national jurisdiction. A third of the world to be really embraced with proactive care, as if our lives depend on it, because they do. We've taken nature for granted. And so far, so good. I mean, we can still breathe, but we can look at the trends. The trend is not in our favor. It's not just rising temperature, it's loss of biodiversity. It's changing chemistry. The solution is, well, how did we get a planet that works in our favor in the first place? Well, it was a natural world over many millions, hundreds of millions of years. It's taken us a very few decades to unravel those systems. But we can change, knowing that it matters, that our lives depend on looking at the natural systems with respect, not just from what we can take out as products, but we can take our existence from nature. Those mangroves, they really rock. We can do a lot just by starting there. Protecting the coral reefs, protecting those microscopic forests in the ocean, now that we know how much they matter.
Thank you so much, Sylvia. We have time for one very last question. Thank you for all your questions. And I think this one is for you, Riddell. A very short answer, if we may. It comes from Tracy Van Wiel from Perth in Australia. And she said you spoke about food security, and she comes from a farming community where their family have farmed for over 120 years. And they have great concern for what will happen in the future for food security in the region. And her question is, what are we doing to protect food security and that for our next generation?
Well, Liz, you know that with climate change, food supply could be affected adversely. Rainfall patterns will change. Some will have higher rainfall. Some areas will have lower rainfall. Sea level will rise. And deltas like the Mekong Delta, which is a major rice producer, will be affected. Warming temperatures will affect the growth of crops. And of course, cyclones can kill them. So what are we doing? Well, there are researchers going on, as we will see in the film. I don't want to anticipate the film, but for example, the International Rice Research Institute is developing varieties that can thrive in different environments. Not only that, but we also want to work with smallholder farmers, teaching them how to better cope with the vagaries of climate, the changing climate. There are so many things we can do, but we have to start now. We cannot keep on waiting, especially in developing countries in Asia. We have to capacitate our farmers so that they will be more food secure, and also as well the whole nation. Thank you, Liz.
Thank you, Riddell. And with that, I'm going to wrap up the Q&A session. I'm going to hand over to Ben Horton to do a summary of thank yous, and I will come back for a last minute mention. Over to you, Ben.
Thank you, Liz. First of all, I would like to thank all the scientists, particularly the EOS scientists who participated in the Climate Impact Asia series. I'd like to welcome the new partnership with the CuriosityStream and StarHub in the region. We hope this is the beginning of a number of important documentaries about the climate emergency in Southeast Asia and also regarding geohazards. Our vision at the Earth Observatory of Singapore at Nanyang Technological University is to build partnerships in the region. We wish to share knowledge, build education, support community development, and quite simply be the leader for geoscience research, mitigation, and adaptation in Southeast Asia. Personally, I do not think there has ever been a more important time to be an Earth scientist.
That's right.
Liz?
Thank you very much. There's nothing I can say on top of that, except to read out a few quick messages I've had. Bravo, Sylvia Earle, a very timely reminder for all. And my deepest thanks to Dr. Sylvia Earle for her passion and her calm manner I am bowled over by you. Thank you so much, Dr. Sylvia Earle and Dr. Horton and the whole team at EOS for the work you're doing in the region. Just 3 messages that I would like to read out. Thank you all for joining us today for the launch of Climate Impact Asia. I'd also like to thank those that joined us from the US, from CuriosityStream. I know it's the middle of the night for you, from StarHub, from our partnership that we're building with you. We look forward to working with you again next year. Thank you all, and I'd like to go out with a short 4-minute trailer with a little bit more of a teaser for what you will see this weekend. Be prosperous, stay safe, and have a wonderful rest of the week. Thank you all, and we'll go out on this trailer.
Earth science has never been so critical to the understanding of what is happening above and below the Earth in our changing climate system. Across Southeast Asia, there are over 900 active or potentially active volcanoes and a myriad of major tectonic fault lines that are constantly shifting. By 2100, over 1 billion people on Earth will live in low-lying coastal zones, subject to flooding on an annual basis. 70% of these will live in Southeast Asia, one of the most vulnerable regions in the world to climate change. Understanding the risks of coastal hazards like typhoons and tsunamis in a rapidly changing climate system has never been so critical. Food security faces many challenges due to climate change. Rising sea levels, droughts, increased temperatures form a myriad of issues that require urgent solutions to ensure even humanity's most basic food, rice, are met. Over 90% of the world's rice is produced in Southeast Asia. Over 4 billion people rely on rice as their major staple food. As a crop, it is acutely sensitive to changes in the climate. Understanding these in a rapidly changing climate system has never been so critical. Can science and technology work together to deliver a sustainable future? Scientists at the Earth Observatory of Singapore are committed to find long-term sustainable solutions for a brighter future. Across Southeast Asia, our stable climate system is changing rapidly. The atmosphere is warming at an alarming rate. Floods, droughts, earthquakes, typhoons, and volcanic activities are increasing, and the ice sheets are melting. All are having a critical impact on every aspect of life we rely on for our survival, which all require long-term thinking.
Many people now know that climate change is real, that they see the data or they see the observations for themselves. What's needed now is a sense of urgency. We have, within the next decade, exceedingly important decisions to make.
Climate change is a very real threat to agriculture. It's also a very real threat to the way of life that we have right now.
Let's think about a world in 2050. Maybe the storms are bigger. They might be less frequent. But how do we prepare coastal communities for this? We need better coastal cities. We need better engineering. We need to keep people safe, and we need to communicate exactly what to do when an event is coming.
One thing I've learned when I've been studying earthquake hazards is that you can't just look at one part of the system. You can't just look at the faults. You have to look at how people are living on the Earth's surface and how they're using the land to understand the whole hazard.
The Earth Observatory of Singapore plays a critical role in helping to understand how our dynamic planet works, acquiring and sharing knowledge on some of the most complex natural phenomena and changing climate systems with government and communities will ensure a more sustainable human presence in Southeast Asia in the future and make the world a safer place.